I wanted to derive the formula for resistors in parallel, and I learned a few things that I haven't seen taught in class or on YouTube channels, so I'll cover that here. As with all my videos, I just figure this stuff out on my own and make a crappy, no-budget video. And I do this because I haven't seen this anywhere else, so it's kind of nice to add to the overall collective amount of information that's available on the internet and YouTube. So if anybody sees any errors, let me know. I just figure this stuff out and I'm still learning. I have a diagram here of our ideal elements, voltage, resistor, and then our conductor. Ohm's law, voltage over resistance equals your current. But something I've never seen explained this way is you could actually pull that R out and make it 1 over resistance times voltage equals your current. So if the number on your resistor is 2, that means you're going to have 1/2 of the current allowed through for any given voltage. If the number on your resistor is 4, then that means you'll have 1/4 of the current coming through for that voltage. So the number on your resistor simply gives you the fraction of the current that's allowed through. Now let's look at resistors in parallel on our ideal circuit here with ideal elements. There's our voltage source here, goes up, branches off through 3 courses, resistor goes through resistor 1, 2, and 3, and then all of these combine back down to right here. Here's what each number means with Ohm's law. Resistor 1 will give you voltage over current 1, same thing with resistor 2, and same thing with resistor 3, voltage over current 3. The amount of current that flows through here is a measure of voltage over resistance. So it's voltage over R1, resistance 1, gives you the current here, current 1. Same thing with current 2, voltage over resistor 2 gives you current 2, and then same thing with current 3. All of these currents flow through here just like water through a pipe. So you have a current flowing through each pipe. All those currents are going to combine, and you're going to have that amount of current traveling all the way around. And then down here you'll have your total current, and that'll equal the voltage over your total resistance. The formula we use for adding up our resistors in parallel is actually, what we're actually doing is adding up all of our currents. We take current 1 right here, plus current 2, plus current 3, and that will give us our total current. But we're adding up our currents in terms of resistance by saying voltage over resistance 1 plus voltage over resistance 2 plus voltage over resistance N, whatever, and that will give us the total voltage over total resistance. So what we're doing here is taking current 1 plus current 2 plus current 3 to get our total current. So current 1 plus 2 plus 3 all combine to give us our total current. And there's the formula for each current, voltage over resistance right there. And that's how we get our formula for our adding our resistors in parallel. What I did here is I just took total current equals the same thing as voltage over total resistance. We have a V in the numerator all along here, which means we can multiply both sides by 1 over V, or divide both sides by V. 1 over V times all this, 1 over V times all that. The V's will cancel, and thus we have our formula for adding resistors in parallel, which is actually, like I said, what we're doing is adding up our currents. To get our total resistance, we're taking the inverse of our answer, but if we didn't want our total resistance, we could just leave it like this plus this plus this. Just don't even do that, and we'll get our total current flowing through right there. This works because the equation number 1, which is right here, adding up all of our currents, this does lead to a total current, so we can use that in the formula. Here's the next question I had. If we can add up all of our currents to get our resistance, does that mean we can add up all of our resistances to get currents? Turns out no. Right here I did current 1 plus 2 plus 3 gives total current. So if I do the same thing here, resistor 1 plus 2 plus 3 will give total resistance. But this formula works for resistors in series and not parallel. So for example, instead of taking V over R1 plus V over R2, yada yada, I could take V over I1 plus V over I2. This does not give, see how all this will give voltage over total resistance. This will not equal voltage over there. This will not equal voltage over total current. comes out to be a difference, I believe, between the labeled resistance versus the effective resistance. Each resistor will have a number labeled on it, so when you add all those up, you get a total resistance, and that'll be your labeled resistance and your effective resistance if they're in series. But if all these resistors are in parallel, then this will just give you the labeled resistance, like the number that's labeled on each resistor, and it won't actually give you the effective resistance because that'll be less because everything's in parallel